Awesome. Clarice, thank you. Now we are recording and we're talking about red-green refactor and test-driven development. Um, and actually, we're coming to my favorite part, which is not about test-driven development per se, but part of the idea here too is, as you'll, I'm sure, have discovered, writing code is a lot of fun. Half the challenge is figuring out what do I need and what do I don't need. There's a saying, anyone can build a bridge that stands up. It takes an engineer to build a bridge that barely stands up. The hard part is knowing how much can I get rid of and have the bridge still stand. We all love to write code. Part of doing it professionally is learning what's the minimum I need. Because the more experience you get, the less code you will want to write, because every line of code is a possible bug. Every line of code needs to be maintained. The less code, the better. So this helps push that as well. And there's a great saying. You ain't gonna need it. If you don't need it, don't write it. It is very tempting to look 5 steps ahead. Sometimes you have to. Like, there's clearly times when you need to plan ahead of it and write out some code in advance. Like, especially if you're figuring out like your data structures and the overall program structure. But especially like performance optimization and all sorts of other things. Half the time, if I'm thinking about something I'll need later, I might not even get there. The business might decide to drop the feature, or by the time I get there, when I'm really digging into the problem, I might realize actually this problem is different than what I thought. I need to do it a different way, or something else has changed. It's usually easier to solve the future problem in the future when it actually happens, because you'll actually have better information about how the problem should be solved. It's way easier to trying to predict the future is a whole lot harder. So this is like the golden rule of programming, is that you ain't gonna need it. And it's tough. It is not something that came natural to me, and it still doesn't, but it actually makes life a lot easier and makes code easier to write and maintain. Once the test passes, refactor your code to improve its maintainability, readability, which is very similar to maintainability, and structure, while still passing tests. And this term refactor, there's a whole book by this guy, Martin Fowler, that's one of the classic software books, which I really should read. But refactoring means rewriting code without changing its behavior. So we might change the implementation, but it should do the exact same thing. If my function still returns, a list of arrays, a list of lists, it should still return a list of lists after I refactor it, right? Think about like a black box. I don't have to know what happens inside the black box, as long as whenever I give it the same input, I get the same output. The other great saying here is, first make it work, then make it right, then make it fast. And this is a really good guideline of a workflow for writing code too. Just get the program working. It's so easy to change code. Once it's working, you've saved it in GitHub, then we can make it look nicer. We can make it not be so hacky. We can make it be more maintainable and readable. And then if we need to care about performance, we can do performance enhancements. This is really useful. The last saying I'll share is, plan to throw the first one away. Programming is pretty complicated because a lot of the times there's just so many moving parts, and a lot of what we're doing is actually really understanding the problem. And sometimes the best way to understand the problem is to build a solution to it. And once we have our solution, rewriting the code again does not take as much time as you think. It will in the beginning for you all, but once you start getting syntax down, you realize the time-consuming part is understanding what the program should do, not writing the code. So once you write the first one, even if it's hacky, rewriting it again and having it be cleaner and more organized is actually easier. And it's usually easier to do like a rewrite than modify existing code. As programs get bigger, that's not so true, but there's some truth to that. So why test-driven development? Reliability, documentation. Tests serve as great living documentation. Maintainability, collaboration, TDD, and pair programming often go together. I'll throw workflow on this list. And regression testing. Regression is when a bug is fixed, but then happens again. This is shockingly normal. We're all working on a code base. We find a bug. I fix the bug, but I don't write a test or document it. 3 weeks later, someone else is working on a feature and does the thing that produces the bug again, because usually bugs are not, it's not obvious. People usually think they're, you know, this is a good idea. There's just this weird edge case. So when you fix a bug, you write a test for it because inevitably someone or something else will reintroduce the same bug. So you guys saw a bit with Jest. And did Francisco talk about some of this yesterday, sort of big picture TDD stuff? Yes, no, maybe?
Not that I remember.
No, I don't think so.
Okay, we probably are saving it for today, which makes sense because honestly, it's pretty great doing it with Pytest. We are introducing more and more tests into the program. Some of the assessments, you'll have tests you need to get your program to pass. A lot of the daily assignments have tests. Employers love tests. As you will learn, a lot of what employers really care about for software engineering is not the exciting stuff. It's the stuff that seems boring, like tests and proper naming and documentation. So this actually really moves the needle in terms of all of your competitiveness on the job market. Let's see here. Oh, the foo is somewhere else. I won't worry about it then. Where's my notes file? I just want to commit this. As I said, I'm obsessive about making sure I don't lose work because I've had it happen too many times. Cool. So we're going to use, NPM has Jest. It has other libraries as well. The most popular library with Python is really Pytest. So I am going to create a Python virtual environment, install the Pytest package, and we're going to write some tests. -M stands for module. We now learned what a module is. So somewhere in the Python standard library that got installed when we installed Python, there's like, I don't know, the file itself is probably not named venv, but there is a virtual environment package. And I'm just going to create it right here. And of course, I keep forgetting that I need to use Python 3. One of these days, I will fix my aliasing. Got my bin, my include. I'm going to create a git ignore file because I don't want, I really actually should have done this differently. Forgive me. What I wanted to do was this. A good practice, Python virtual environments. Inside your project root directory, create a directory name .venv. And the fun part is VS Code will pick up on that by default. And now I should be able to activate my virtual environment. And now I should be able to, it should pick up on my Python virtual path. I'm not going to worry about that too much for our purposes right now. Maybe opening up another VS Code here will do it. There we go. It's because when you open VS Code sort of with the Explorer window and the folder or the directory that you choose, VS Code sort of assumes that's your project root. And maybe I just needed to refresh VS Code. There's other ways to do this too. But a couple fun things to note. My Python virtual environment is still activated in the shell session, which I'm actually a little surprised by. But VS Code, now if I'm telling VS Code what version of Python do I use, where should pip install stuff, all these good things. Well, pip is really from the Python virtual environment, but a couple VS Code stuff is easier with this. It picks up on this .venv directory. Now I do want to create this git ignore directory. And now inside it, I do want to put the virtual environment because we don't want to check that into version control. So there's a little setup there. The more you do it, the more it becomes second nature. Now when I use pip, it's going to install Pytest specifically into that directory. Remember that the virtual environment, it's just a directory that does a couple scripts that changes our shell path. And it really just means when I install pip, when I install Pytest, it's inside here. We could install Pytest globally, but it's good practice to do it this way. And actually, since my Python stuff is a little goofy, that should be fine. That's fine. This is just telling me I should upgrade from version 20 to version 23. But every now and then when you upgrade, something breaks. So I try never to upgrade when I'm in the middle of something else. So this is great. I've installed pip. Just for fun, I will demonstrate. Let's see here. I think pip freeze. So if I run this command, it shows all the Python packages I've installed. If I use this pipe command, it will put it into a file named requirements.txt. And the convention with Python projects is to put your project dependencies in a requirements.txt file. So this is a bit of a digression, but this is also, I think, really good to see because this is sort of the standard flow for setting up a Python project. Actually, let me pause and see if folks have any questions. Oh, and Francisco, thank you so much. It looks like I actually led us down a wrong path here and installing pip global Pytest globally. And that probably makes a whole lot of sense. I'm so used to like the world of Node.js and NPM, where often you want to like install those dependencies on a project specific basis. And I agree with what you're saying in the chat, Francisco. Like we can just install Pytest globally, and probably don't have to worry about that here. So Francisco, I will check in with you about best practice for what Python packages to install globally or not. So I was about to say something and I was like, wait, I should double check. So I'll make sure that we're on the same page and giving all of you good advice. Installing Pytest as part of the Python environment isn't going to break anything, but doing it globally definitely makes it easier. And you're right. Like if all we need is Pytest, then we don't have to worry about the virtual environment. Moving on and closing these files out just for fun. Let's run Pytest. And voila, our test session runs. There are no tests, so nothing happens. But hey, it works. It's running, and that's a great start. And we're sort of red-green refactoring already. We know that things are working, that Pytest works. And that's always worth doing as well. Yeah, the other advice that I want to share is always be running your code. So I'm going to create two files now, test example py and example py. I'm going to remove the Pytest py because there's nothing in there at the moment. And let's open up both of these and let's follow our test-driven development flow of red-green refactor. Let's say that our task is we want to write a program to add two numbers. So, in fact, what I think I'll do is I will do this. We were talking about pass and what is it good for? Well, this is a good start. I haven't really done that much work, but this gives me a method I can import into my test. So each test, you write individual tests and you can chunk them together into blocks. And it can be useful because sometimes you want to do some setup that you use for one or more tests. But the idea is also you want some isolation because when you run a test, you don't want whatever's happening in there to screw stuff up for the next test. So the way that almost all of these test runner programs work, and I think that's probably the right term, like a test framework or a test runner, it gets a little more specific, but that's a pretty good starting point, is oh, I'm sorry, I'm just catching up on the chat here. I'll catch up on the chat a bit later because I don't want to get too distracted. But for most, like each individual test is its own function. And when we run Pytest, it will execute each of these functions along with some setup work. And when we write a test, we do what's called an assertion. And this should be a little familiar from Jest, correct? Same concept. That's the beauty of it. And remember the way that like Boolean logic, conditional logic works, I don't need an if statement. This returns a Boolean value. Like, let me open up another thing here and just very quickly do this and clear a little space. And this is why it's great, like having a Python REPL just running in a terminal. Right. So just these sort of comparison statements, I mean, you could almost, this is getting a little out of scope, but if we were to like design and build a programming language, we could write lambdas or functions and just assign them to these symbols, because this is basically a baby function returning a value in some sense. And so that's what's going on here. A comparison returning true or false. And this assertion does one thing if we get true and another if we get false. And because we're on the red phase, and in fact, let me go ahead and split. Is everyone comfortable with the split screen? You still have context? Yeah. And honestly, a lot of the times it's great. And this is where having a nice second monitor is great. Like in a perfect world, if I'm going a little nuts here, like I get a little obsessive about this stuff, though I am not the only programmer, but it's sort of like a heads up display. Like now I've got my split code, I've got my command line to run tests, and I've got my Python REPL where I can just type stuff. And I don't have my VS Code really customized and set up the way I would for serious work, but then you'd want a keyboard shortcut to jump around really easily. Anyway, point is, we haven't even set arguments for this yet, but we are already, and in fact, let me use the Control P or Command P command in VS Code to jump to that file. In our test, we are already passing arguments, even though we're not handling that. That's okay. This is the red phase. And there is definitely something I'm missing here. Oh, of course, I need to add the name of the file that I'm giving to Pytest. So Pytest space name of file with the tests in it. I'll make this a bit smaller so this is easier to read. So this is great. We got a failure. We got the red, which is what we want. Add two numbers takes 0 positional arguments, but 2 were given. So first off, I want to point out, when I wrote this assertion, I didn't mention at the time, but this one, it's pretty obvious with add two numbers, but half the value of writing the test first is it makes you think about what the function's supposed to do, what it's supposed to return, what its inputs are supposed to be. Here, it's pretty clear that 2 and 2 should be added up to 4. So that I just kind of threw that in there without thinking about it. But that's actually like half the value of this red, green, refactor test-driven development workflow. So in the spirit of that, I'm going to add 0 and 0 and run my test again. I'm making one tiny change. We're still red. In fact, now do I have a typo? I must. Of course I do. I'm so sorry. Let's just call this A and B. I need variable names. They're not values. I was thinking of tests. Let's try that one more time. So, tiny change. Actually, my screw up there is a great example of why it's great to just run your code after every little change, because especially staring at a screen all day is just easy to make errors. So now we have a new failure, which is better. The inputs to our function match up. Now the outputs don't match up. And there's this term, function signature, which is referring to the inputs and the outputs. How many inputs, what type of inputs, strings, integers, what's the output, what type of output. So let's just return hello. This is still obviously gonna fail. But now we're moving forward, right? In fact, maybe I want this to be return 4. So here's a great example of why you have to be careful in testing. My test passed. Is this function correct? Very clearly not. So you almost always write multiple tests. You could even, use a range or stuff like that to not have to write each test case by hand. But let's do maybe like even and odd. The other thing, start thinking about different kinds of data. This is a contrived example, but it's good. It's good to be thinking about this. Even and odd, maybe 1 is 0, and we want 1 negative number. Maybe we want both negative numbers, right? This is a contrived example because this function is very simple, but thinking of like the different kinds of inputs you could have is really good. And how about 4 and 8? And in fact, I'm going to, and that should be 12. Again, part of the value of writing the tests is it forces you to think about what your program should be doing. The risk here, as you can see, is if I get this wrong, my test is wrong. Maybe how about 1 and 3? And I might be like breaking out of TDD, strict TDD here. I will admit some people are very strict about test-driven development. I have gotten much better about it, and there's a lot that I value, but I've never been super strict on it. But the important piece here is this red-green refactor flow. We're still going to have a bunch of tests that fail. Really, I guess I should be adding one at a time. Excuse me. And, like an extremely big number, like 20 million. For this, it's so simple that it doesn't really matter, but things like that are good to think about. And in fact, let's just do negative 500 and I don't know, 1. And like a decimal would be good as well, unless we want to restrict this to integers for any reason. And in fact, I don't know, how about negative 5? So now we have an extremely robust test suite here, so to speak. And let's run this again. And you can also see how testing could take up so much time and how it's always a balancing act. And now I do have a bunch of failures. And in fact, I think what I'm going to do is, I guess there is a more elegant way to do it than what I'm about to do now. You can like add in little things as you write tests so that only certain of them run, but simply having 2 is not the worst way. So my first test passes. My second test fails. It might be time to make this real. Right. Now we're looking good. That one's working. Let's add these in one at a time, because if I add them all at once and one fails, then it'll be harder to debug. And voila. We got red, we got green, we got refactor. I'm going to do some even more refactoring. Let's just like num1, num2. I see a couple hands up. I'm renaming my variables. I'm making sure they work. And yes, what's up?
I originally installed the Pytest in a working directory, and then I think I tried to delete the hidden folders from there, and then I installed it again at the root. But I'm getting errors about import files being mismatched.
Remind me, and let's look at that. Can you share your screen real quick and show me the error?
Yeah, sure.
Thank you. Then let me stop sharing so you can do that.
Do you see my screen?
Yeah. Import file. Is this file attribute local lib, which is not the same as the test file we want to collect. Type ls for me. Delete that pym config file. Type which space pytest and hit enter. Try Pytest running Pytest with where's your test file? Oh, it's the pytest.py.
Yeah.
Just
there's example.py.
Let's rename pytest.py. I might have led you guys down the wrong path there. Use the mv command and rename pytest.py to test_example.py. I'm not certain. It's always possible, since a file is a module in Python, that Python is like, we have two modules with the same name because of that pytest.py file. So I might have led you all wrong there. Now let's try running it again. So pytest space test_example.py. Let's see what happens.
To move it, I hit that, but it didn't.
Oh, I'm so sorry. The command would be mv space pytest.py space test example.py.
Okay.
So yeah, when you use, and what that really does is rename.
Sure.
That's sort of how you rename on the command line. And now, yeah, let's try that and see what happens. Let's see what the error is. If you scroll up a bit.
Looks like at least a good error.
Can you that looks like actually like a syntax error. If we look at the very bottom of the error message, it says syntax error expected $. So I think we actually may have made a little progress there. What I would do, close out that pytest.py file in VS Code, especially since we deleted it, and open up test example.py.
I think the name of that function was not correct.
Yeah, test add two numbers is a function. You have test different, separated from add two
Yeah,
numbers.
there should be a underscore.
Oh yeah, that would do it. That would, let's try running it now.
Okay, I think it's actually
so
add
the
two
name
numbers is the.
your example PY looks good. Hop over to the test example PY function. And thank you guys so much for saying that. I didn't spot that at all. Can we look at test example PY real quick, please?
We can. The problem is I'm sharing my VS Code and not my screen, so it's a little hard to see everything.
Got it. Cool. So, yeah, we need on line 3, the name of that function should indeed be test add 2 numbers. Test underscore add 2 numbers on line 3 in test example PY.
The one that I've got from the source is just add 2 numbers.
Correct.
But okay, but I still do test. Got it.
We are creating 2 separate functions.
Okay, I see.
Yeah, I'll walk through it in a second. Actually, this is a good one to reiterate. So we create the function add 2 numbers. That's the function we want to test. That's the one we import into our test file. The way we write a test is we write another function. So you can think of it almost like a wrapper. So this second function that contains the test, we are naming test underscore add 2 numbers, because that way we can read the name and it's clear what we're testing. And inside that, we call the function that we want to test. And now on the command line, try running this file, test file with Pytest, and let's see if it works. And you can just hit tab to autocomplete for file names and stuff. Awesome.
Yeah, cool.
Yeah, good job. Yeah, this was a good little debugging session. So the clue in that error message, by the way, was at the bottom. Usually the clue is in the bottom or the top of those big, scary seeming error messages, and the rest you can ignore. And the clue for me was the syntax error with parentheses. And that told me that we have a syntax type issue. I missed the actual problem, which you other guys caught, which was that we had that space there, which was messing stuff up. So yeah, awesome. Good job, guys. And I think someone else had a question.
Yeah, I did. And we can disregard this question if I'm jumping the gun, but to as an example, for when you're giving these test cases, you're making these functions that test things inside of our core file that has the functions. We have a problem that like the one that's for the assignment for tonight is 99 bottles, and it's a lot of text. And like you want to assert that what your output is matches exactly like 99 different printouts of text with just one number going down, you know, there's a more efficient way to do that, right?
Let's take a quick look at the assignment. And then we'll return. We hit the high points with testing. I think I'll briefly walk through, honestly, probably our lecture doc, just to point out some of the really nice tools that you get with Pytest for writing tests. And then we will look very briefly at actually running some code for monkey patching, because that one is good to see. But let's very quickly look at that problem, because I totally get where you're coming from there. So if we kind of travel around our repo here to today's lesson. And which would be, I traveled too far back. Here we go, 99 bottles. Write a program that can print the song 99 bottles of beer. The song 99 bottles of beer on the wall, blah, 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 blah. This certainly is a lot of text. And your question is basically, how do I test this? This is a lot of text. Matthew, what's up?
I mean, I was going to say, couldn't you just test the values that need to change since everything else is static? You just need to really test the 99. And then in that last line, you have to make sure that bottle, it goes to singular. So you really don't have to test like everything. If that makes sense. Can't you just kind of do like a way to search a string to see if it matches?
Right. So you actually raise a really good point. There's actually a couple really good points in here on that. Let me circle back to that one. And let me sort of start from like simplest approach to somewhat more complex approaches. So the simplest approach here is the task is writes a program 99 bottles. There is a little bit of not trickery, but getting test data, it can be a bit of a task. On a practical level, it's probably easiest to write the program and get it working and then copy and paste the correct output and use it for your test. Although that, of course, is not proper test-driven development. One approach, though this is increasing the scope of the task, is maybe we modify the program so that instead of 99 bottles every time, we pass in a number, and that's how many bottles of beer we have. So maybe 2 bottles of beer on the wall, 1 bottle of beer, take one down, pass it around, no more bottles of beer on the wall. Or even better, 1 bottle of beer. Talk about starting with the simplest possible case. So this does make it more complicated, but now all of a sudden it's dramatically easier to write a test. And I can do it for 1, and I can do it for like 5 and maybe 10, and then sort of call it a day. That's one approach. To be honest, another approach, even if we don't do that, while this is a lot of lines, it does not actually take that long to do a little bit of copying and pasting and getting what the output should look like. And yes, that is a big string, but it is just a string. It takes up an incredibly tiny amount of space in memory. So there's not necessarily anything wrong with that either. Just manually, like fudging and copying and pasting your test data. And honestly, I'd like just write a program to print out like 99 down to 1 and then do some copying and pasting with like the rest of the sentence or something. And that's a valid approach too. And this kind of goes into like, there's a lot of testing strategies, and designing tests is definitely a thing. And in a lot of ways, the simplest way is probably the choosing the number of bottles of beer. Yeah, what's up?
Yeah, I was saying, I think that last part that you said, that was a good like period to what I was gonna say, because I think I got what I needed, especially the part where you said starting from the bottom, for the sake of you wanting to finish your Pytest lesson.
For sure, yeah, we should wrap. The couple other things I do want to point out on this, though, as you were kind of hinting at, we can write one test to make sure that it prints out this last bit, right? The 1 bottle of beer. That's probably like one test for this part right here, because we know it's always going to be there. So that test is easy to write. The other piece is, there is a little bit of an overlap between like testing and program design. If we know that every time we run 99 bottles, we always want to print out this bit at the end, we could honestly just write a function that does this and call that, and write a test just for that function. We could write another function that generates this line, right? 99 bottles of beer, 99 bottles of beer. And we just pass it a number, 95 bottles of beer. So we can start breaking our program into little bits and testing each little bit, which is called unit testing. We could have another function for this. And so that's another strategy as well. And that one is more sophisticated, but that is how a lot of tests get written. And then to kind of go back to the point and this does come back to some of what I wanted to cover. Pytest gives us some very useful tools. We saw this simple assertion. Unsurprisingly, we can use all the other sort of equality type operators or comparison operators that the Python language gives us. We get a very nice assert equal, which honestly makes things easier to read. Like instead of assert this equals 4, you know, I could just do assert equal add 2 numbers 4, and that does the same thing. Though apparently I probably need to import this. Oh, it's not the import. We may just have the wrong name there. Sean, yes, sir.
Yeah, I was just wondering if you can loop through test cases, or would you have to like specify each one?
Yeah, that is a great question. So the beauty of all this is just Python code. So we can do all the good stuff that we already can do. Like for instance, what is it? For I in range 0, 10. Assert so it gets a little tricky because this is not correct Python code. I know I've got something wrong here probably with the range, but you absolutely can and will often write loops or do stuff to do like that. What you want to avoid in your tests though, you kind of want your tests to be dumb. Because if you screw up the test, then you really screw up the test. And the fact that my answer is not hard coded and kind of depends on this loop, like at this point, I've got logic here. I'm like writing the function and the logic twice, and it's sort of it's sort of like a self-reductive test, if that makes sense. So you absolutely can and will do loops and stuff, but you kind of want to keep your tests dumb, and actually hard coding the correct test values is not the worst thing in the world. Clarice, yes.
Speaking of loops, what exactly is the kill switch on the terminal? I've had a couple infinite loops and I don't know how to stop it without closing the program.
Oh, great question. Control C. I think Control D sort of forces it more, but usually if I've got an infinite loop, I just hit Control C until it stops, like while true. Oh, it's yeah. I can't get. I'm not. I can't. It's too annoying to try and do it in the REPL there. But Control C. I think the one thing I do want to mention is like monkey patching and grabbing terminal output, because that is quite useful. So I'm just going to very briefly touch on that, because that is what we will see. You know, this is an awful lot of tests for adding 2 numbers together. This is more to like show the example. And there is an element of practicality here, but the workflow and forcing you to think through stuff, like it actually can help you think about better program design. But let's say we have a program where we are getting user input from the terminal, which is what this input function does. Right, and in fact, I'll just run it here and we can watch it in action. After this, we'll we'll break before stand down. And honestly, since we've pretty much been doing lecture all day, and again, I really appreciate everyone's patience today. You know, we'll just wrap at the end of this so we can just call it. And if anyone writes code tonight, we can see it in the morning. Otherwise, maybe Francisco and I will do a quick demo, and then you guys will have the 3-day weekend. But to write code. So, you know, I've got my number, enter a number, I return it. Beautiful. How do I test this? A little bit trickier. So this is where something called monkey patching comes in. That's sort of basically like the fake it till you make it of programming. And let me make sure that I get this right. So we want to also now import get user input. And we now want to write another test. And it is nice to just write your test functions following this convention. And monkey patch, I believe, kind of sort of comes with Pytest. And we pass it as an argument, and we can use it to simulate user input. So it lets us like hook in to our program. And there is, I'm not sure if this is a property. No, this must be a function, but we're going to set an attribute. And this is, you would have to kind of read the docs to know what to put here. So we're giving this to you, and you absolutely can and should just use this. And then if you're curious, you can Google more if you need more. But as you can sort of infer, we're monkey patching, we're hacking to like simulate user input from the terminal. And we're actually going to use a Lambda function, which is going to work great. Because the way that I think this monkey patch set attribute function works is it expects a function as its second argument. And the reason you often see this where like functions are passed around is because it's incredibly flexible, right? Monkey patch has no idea what you might be monkey patching. By passing in a function, I can put in all sorts of things. I think this is going to print out. I'm putting this to sort of like test my test as I go. The other golden rule of testing is like tweak your test data to make sure your tests fail in the right way. And let's see what we get now. I think I'll just close this out because we're not using it that much right now. So that passed. My print statement didn't come out. And let me shift stuff over so we can see a little better the code. So there's good news and bad news here. The good news is my test passed. I feel like things are working. The bad news is, how do I know if my test is correct? The answer is I don't. So a best practice when writing tests is let's force the test to fail to make sure it fails when it should, because that's as important as succeeding as it should. Because just like we saw where I just return 4 all the time, just because the test passes doesn't mean everything is right. So let's do result equals 5. And we know that should be wrong because we're passing 42 in as the input. So I am expecting this to fail. It does. 42 is not 5. That is great. My test is working. I have tested the test. I can change it back now to its correct value and commit that code and have it go through code review. So that is something that's really good to know. And I think I will just, well, let me quickly see if folks have any questions, actually, before I show the last 2 bits.
Can you show the rest of your monkey patch test?
Do you mean sort of right up the rest from the lecture or the rest of the monkey patch test that I wrote?
From right there, yes.
Yeah, absolutely. Yeah, there's not that much to it. The lambda, you know, we can Google. Let's see if we get. Yeah, I'm not sure where monkey patch comes from because we sort of have to pass it in as an argument here. I'm pretty sure if I dug around, it's coming from Pytest, and we sort of get it for free. I might, if I had sort of my VS Code and Python environment set up a bit better, we might get better hinting. But it's worth taking like 5 minutes to read about like Pytest monkey patch. Like if I was seeing this for the first time, I would just Google Pytest monkey patch. My rule of thumb is I don't need to go. I kind of divide my professional learning into like 3 levels, like level 1, 2, and 3. Level 1 is just I know it exists. Level 2 is I know enough to learn more about it if I needed to, or level 1, I guess, is I know it exists and I know where to go to learn more if I needed to. Level 2 is I have a decent amount of familiarity. Level 3 is like I know in depth. And my goal is whenever I'm programming or learning stuff to get everything to level 1. So whenever I see something I don't know, I just take a second and I Google it. And all I need to see here is, all right, monkey patch comes from Pytest. It's got these properties, which is nice to see. It's got like environment variables. It looks like we might not even need to pass in a lambda. It does seem to want lambdas. And this is really all I need to know for now with monkey patch. The important thing is I know enough now that if I need to go deeper, I run into a problem with monkey patch, I'm not starting at 0. So anyway, so yeah, that's monkey patch and one nice use case for a lambda. I won't code out examples, but I will point out what we have here as examples that are probably worth coding out or using. Just a bit more with monkey patch and simulating user input. And then just as importantly, capturing terminal output, which can be useful as well. Like here's a print statement and here I'm capturing it and here I can run a test. So these are very powerful things. So this was a long day, but we have been introduced to so much. And this is welcome to the wide world of software engineering. What questions do people have? Everyone kind of ready, feeling a bit done. Francisco, I think, are you in the chat, so to speak?
I am always here, Adam.
I forget. That is. Yeah. No, I was gonna make a drill instructor joke about like being in your dreams, and I realized I should probably just stop while I'm ahead. I was just gonna say it's been such a long day. I'm wondering if we should just wrap and call it now for stand down, and then in the morning, if anyone has code that they do write that they want to share, they can do it. Otherwise, you or I can maybe like demo or write a little code from one of these problems.
Are you